Okay, in the previous session, we created our first script and run it with different scenarios. Today, I'm going to elaborate JMeter main KPIs. This is Daniel. Let's get started. Okay, as you can see, the snapshot show you some main KPIs from the JMeter summary report. The first one, samples. The samples indicates how many requests have been sent out from the client to the target system, and is grouped by the label. Okay, average is ART. We call it average response time. It's the average elapsed time of a set of results. Also, we have a mean and a max. STD deviation. Yeah, that's standard deviation of the sample elapsed time. Standard deviation measures how the response times are spread out around the average response time. A small standard deviation means that the response time of all the requests are close to each other, which leads us to understand that a smaller standard deviation value, the closer the response times are, and the more consistent the transaction is, the stable the application tested. Okay, and we have error percentage. Yeah, obviously that's the percentage of the request with errors. And we have a throughput. This one I'll show you in the next slide. And we have a received KB per second, the send KB per second, and average bytes. Yeah, that's another point of view about the throughput. Yeah, they are talking about the package size. This one is the throughput measured in kilobytes per second is received package size from the target system, and this one is what JMeter sent out to target system. Okay, this one is the average bytes, so it's the average size of the sample. Response in bytes is not per second, it's the total size. And the throughput, yeah, this is another point of view about the throughput. We usually call it the TPS and the QPS. And this throughput is measured in request per second, minute, or an hour. And the TPS is the transaction per second. QPS is a query per second. So generally the throughput we can calculate it like this way. Usually JMeter use the total samples divided by the total elapsed time. So the way to calculate throughput is very simple. And so what is TPS? What is QPS? Let's take an example. If we have a logging test, so we create a transaction logging, and under logging transaction we have 3 single requests. So D3, 1, 2, 3. And so each single request we call it QPS. That's the single request to the application server. So we look at the throughput from the single request level. And the transaction, we can call it the TPS. That's from the transaction level because the transaction includes different requests. So that's more like from business logic level. Usually we use TPS. Apart from the main KPIs from summary report, I would like to introduce 3 very important KPIs. So the first one, connection time. This one is calculated from TCP connection level. It's not HTTP level. Yeah, this one is time taken to establish TCP connection. After TCP connection, then the client send further request to the target application system. So TCP handshake is successful, then client can send further request to the target system. If not, the client can't talk to the server. This can happen if the server is not live or busy responding other requests. Okay, so just be aware of that. This one is from the TCP level. And the latency time. Latency is the difference between the time when request was sent and the time when response has started to be received. Okay, so the connection time is included while calculating latency time. And the response time is the same thing as a sample time, load time, or elapsed time. So it could be a difference between the time when the request was sent and the time once a response has been completely received. So this one, the response time, is completely received, and the latency time is just started to be received. So that's the big difference. So in summary, response time is always greater than or equal to latency time. The larger the file is, the larger the difference between response time and the latency are going to be. Okay, regarding the response time, I want to give you a little bit insight about how it works. So as you can see, we have a client. This is where we send the request, and this is a server. Generally, the server includes the application server and the web server. Also, maybe we have some load balance between the client and the server. We have some load balance, and then we have a database. So obviously, we can see the network time is the total time, including the N1, N2, N3, and N4. Okay, that's the network time. And for the backend server, the backend server processing time, so we have a A1, this one, and A3. So that's the time consuming from the backend server side. And then we have a database server processing time. Obviously, that's A2. So if we get a slower response time, we should figure out which endpoint is the bottleneck. So that's what we call performance analysis. And in the following sessions, I'll show you how to do the performance analysis and how to find out the bottlenecks. Okay, this is a classical performance. This is a classical performance curve for stress testing. A stress testing is a type of performance testing that checks the upper limit of your system by testing it under extreme loads. The x-axis indicates the number of concurrent users. That's the load to the target system. And the utilization of CPU indicates the backend server resource status. And the throughput TPS QPS and the average response times show you the trend of the KPIs along with the number of concurrent users. So we have 3 zones in terms of different system load: the light load, the heavy load, and the buckle zone. So in the very beginning, when the stress testing triggered, there are not many concurrent users. System under light load, so not much users there. So the system under light load with acceptable utilization and the throughput and the average response time, everything looks fine. Then the system load is increasing with the increasing of concurrent users. There are lots of concurrent users compared to the light zone. So the concurrent users increasing. Then you can see the average response time start to increasing, right? And the throughput cannot be increased anymore, even starts to decrease. The system under heavy load, and this line is the boundary point. If we continuously increase the concurrent users, then the response time starts to increase sharply, and the throughput start to decrease sharply. So there's no more resource to handle the increasing request. You can see the CPU is almost fully occupied, and no more resource can be used. We call this buckle zone. At this moment, we should stop the testing to avoid the system crashes. So stress testing curve show us how many load the system can handle very well and where the performance limitation of the target system is. Okay, this is a very classical performance curve for stress testing. I hope you can understand it very well. Any questions, just leave me a comment down below and I will try to get you an answer. Next session, let's talk about the Plugins Manager. If you enjoyed this video and find it helpful, then hit that like button and subscribe to the channel, and you have notifications turned on so you don't miss the next video. Thanks for watching. Bye bye.